Thank you so much for having me here today, and I would like to thank you also for organizing this amazing conference and for the people that are here present in this room today. Okay, so I will begin. I want to discuss a little bit in the holistic approach for creating thriving indoor environments. And I want to make it clear from the beginning that indoor air quality or ποιότητα του αέρα in Greek is the key to unlock health for the occupants, energy efficiency and productivity for the employees, and we really have to take it seriously for our future. So let's discuss a little bit about the air quality policies and legislations here in Europe mainly. And we do have WHO, which has stressed the importance of air quality with new guidelines updated in 2021. Unfortunately, the European Union has not yet developed a specific legislation addressing residential indoor air quality. But despite this lack, some countries have taken the initiative and they have created their own framework. For example, even though Italy has not a specific legislation, he has put together two groups, the National Study Group for Indoor Air Quality and the Italian Institute of Health, and they work together in order to harmonize actions related to indoor air quality. Then here in Europe, we also have the Energy Performance of Buildings Directive, which is focused on energy efficiency, but they say clearly that the state members, they have to consider indoor air quality when setting minimum energy performance requirements. And then we do have the European Standard 15251 for indoor environments, where apart from thermal, lighting and acoustics, they do have a specific paragraph about air quality. And we will see a little bit more about it later. Now, it's very difficult to understand what's happening in Europe or in a global scale regarding standards and legislations. And for this reason, a group of people have created the STC 34 Indoor Environmental Quality Guidelines, where there they state all the legislations, standards that they are available in different countries. And today we're going to browse a little bit what's happening with the Mediterranean countries, including Greece. So starting with France, they have already implemented some guidelines about carbon monoxide, formaldehyde, nitrogen dioxide, and others. Then we have Portugal, where they go a little bit further with PM inclusion and radon. Spain has done the same thing, and we do also have some other parameters like variability, humidity levels that we have to have in the indoor environment of all those under the environmental quality. And finally, Greece has very little information, unfortunately, only regarding temperature. And after starting asking people around, because I don't live in Greece and I wasn't aware of what's happening here, I found that we do have a legislation here in Greece about radon, mainly because Europe forced all the states to create a standard and the limit that they suggested not surpassing the 300 becquerels per cubic meter. So Greece decided to create something around that directive with setting the limit at 300 becquerels per cubic meter for residential buildings in an annual average levels, which is a great thing, but we need more pollutants. We have to include all pollutants in order to understand better what's happening with the indoor air quality. The European Standard 15251 states that one way to evaluate indoor air quality is by measuring the average CO2 concentration in buildings while fully occupied with people, obviously. And then they have 4 categories. Excuse my mistakes there. I have written 3 twice instead of 4. But either way, they say that those are the levels, depending the type of the building, that you should achieve. So basically 350 plus what's the ambient air quality level of CO2, which is currently 420 parts per million, if I'm not mistaken. So you have to sum 420 in all of those numbers in order to understand what's the CO2 level in the buildings that you have to follow. However, when it comes to what's happening about other problems inside the building, then this standard says that we have to go outside of the scope and look out in different standards in order to set limits for different pollutants in the indoor space. And in some cases we use the World Health Organization for that, as they have created the guidelines. Most people, in many cases, think that those guidelines are meant for the ambient space, but they are used also for the indoor space. So we should follow those numbers according to the WHO. Now, the European Union is working on establishing a framework for achieving good indoor air quality across the state members, but each individual country will be responsible for enforcing the different regulations. And also there are some other projects out there, like the Global Open Air Quality Standards project, which I'm leading. And this new initiative tries to establish a new benchmark for clean indoor air, with a set of transparent and science-backed standards that all nations and integrators can strive for. So we are a group of experts from the academia, industry, and professional people that daily work actually with indoor air quality, and we are trying to establish standards for everyone around the globe, as we believe that everyone needs to be a subject of the same standard, rather than having multiple standards depending on if you were lucky enough for the standards to be strict enough for you and your health. I would like to share with you a little bit what's happening with the ventilation policies and legislation. Here in Europe we have more, and in many cases we use the ASHRAE standards, the 62.1 or 2, and then we do have the ASHRAE standard 241, which is the newest and better one, and I really like. And then from the European Union we do have many, like the 1525.1 and the 1377.9. For residential and non-residential buildings. What I would like to state with this slide is that ventilation is something complementary, according to me. Why? Because we have to see what's happening with the different pollution levels in order to assist and fix the indoor air quality. Unfortunately, in some cases, people think just by providing air, regardless of where it's coming from, then the occupants are safe. But in some cases, when we bring outdoor air into the indoor environment, we also bring some other contaminants from the ambient space through traffic, or maybe because of some event like a wildfire or a volcano, or whatever the case will be. So we have to be very careful of the air we bring in indoors. I'm also including this slide here where we can see the different regulations around some European countries regarding the air amount that we have to introduce inside buildings and different rooms. And the reason I included this specific table was because it was strange to me that we haven't come to a conclusion of a single unit to use in all those different cells that you can see here. So in some parts of the world, they are using liters per second per cubic meter. In some other places, they use air exchanges per hour. In some other places, they are using volume of air per hour, which I think creates lots of confusion for the experts that they work every day, and they have to compare those data in an everyday basis. Here I would like to compare the newest standard from ASHRAE, which I think is fantastic for protecting the health of the occupants, especially from the perspective of infection diseases. And we will see the previous standard, the newest standard, what's the ratio, the calculated air exchange per hour, and also the equivalent CO2 level in parts per million. I use parts per million, but I know people in ventilation, they use air exchange rates. Now here I would like to describe a little bit to you about the hidden cost of the poor indoor air quality. There are multiple studies out there describing the impact poor indoor air quality has to the occupants, I just state two, very important in my opinion, one of which says that poor indoor air quality with PM2.5 and carbon dioxide in office environment has a significant impact on the cognitive function of the occupants. And another study says that buildings with elevated carbon dioxide levels, then that increase the irritability of some viruses, which leads in a high risk of pathogen transmission. And two terms that are very important to remember is the absenteeism and presenteeism. Two relative concepts. One is that people that don't go to work because they are sick, but we also have the opposite, where people are sick and they are going to work, and then they transmit pathogens and illnesses to co-workers. Let's see a little bit about the economics. So the economics benefit of improving indoor air quality goes beyond just feeling better. Reduces sickness, improving indoor air quality, minimizing transmission of illnesses, obviously, as we have already discussed, and leading to fewer sicker days and healthier costs. And then we do have improvement in focus, as many studies show, the link between better indoor air quality and enhanced cognitive function, resulting in increased productivity. Here is an example of benefit-cost to ratio. This is a study that was released this September 2024, and it was very relevant, so I had to include it. So let's see if worth investing in indoor air quality. So by looking, the benefit-cost ratio only for sickness, we will see a range from 1 to 2.3, indicating that health benefits alone justify the investment of indoor air quality. But then if we combine sickness and productivity, we will see that the benefit-cost ratio ranges between 3.4 and 4.6, showcasing the substantial combined economics and health advantages. There are some other reports out there about the benefits of improving indoor air quality, especially in the office environment. A Harvard Business Review has estimated that the productivity benefits of improving indoor air quality through ventilation, are around $6,500 per person per year. Another study says that using CO2-based demand control ventilation can reduce the energy output of the HVAC systems by 70%. Then the Lawrence Berkeley National Laboratory concludes that improvements made in indoor air quality can boost workplace performance by 10%. And green building certificates in general in the US and other countries have shown to consume 25% less energy than non-green buildings when we look about indoor air quality. So some things to think a way forward. Standards are very important and necessary in order to move forward. Like the ASHRAE 62.1 and 241, including the upcoming GO request, they provide guidelines for ventilation rates and indoor air quality in buildings, and they are very important. Then occupation level, we have to take it really into account as well, because an empty building is not the same as an occupied building from energy perspective, but also from health aspect. And then by monitoring and controlling the indoor environments regularly, we can reduce energy and also optimize the health of the occupants. So in a conclusion, indoor air quality is inevitable in buildings. Poor indoor air quality has significant economic and health consequences. The economic benefits of improved indoor air quality far outweigh the cost, so there is no excuse now. And then finally, we have to take a multi-layer approach involving adopting air quality standards and ventilation standards, collaborating together and raising awareness about this important subject of indoor air quality. Thank you so much.
Thank you so much, Mr. Papathanasiou, for this great presentation. I think it is interesting to see this perspective of investment in indoor air quality and how this pays us back in various ways. Any questions for Mr. Papathanasiou? We can say that indoor air quality is something that also in Greece is a hot topic. All the new buildings are now more well designed with this, and we will keep your advice and hope to have you soon again here for any updates on these standards. Thank you so much.
Thank you so much.